Simon Edwards. I head up software development and product management at Global Inkjet Systems. For those of you that don't know us, we're traditionally known for drive electronics and ink systems, primarily. But over the last couple of years, due to lockdown and other things, we've managed to supercharge our software development work. So we now can offer completely software-only solutions. That means things that don't require our drive electronics at all. And we have developed a lot of tricks and techniques for how to improve image quality purely through software alone. And that's what I'm going to talk about. How hard can it be? This looks like a really easy thing to put together, right? And we see a lot of people doing this. There's a lot of people, a lot of companies around the world, China's a good one to name, where they're starting to put together machines. And it looks quite straightforward. You buy some print heads, you get an ink system, you get some inks, you start to work through that problem, and you forget a whole bunch of other stuff, like encoders, and encoder pitch, and encoder jitter, software, algorithms of software, image management, data flow. How do you get stuff from A to B really fast if you need to do it really fast? And if you can't do it fast, how do you pre-rip it? So it looks easy on the surface, but there's a whole lot of things that can go wrong. And one of the issues, particularly in package printing, is the demand to produce print quality which is similar to non-digital print. And we've heard quite a few presentations earlier today around the idea of being able to use digital print to augment or hybrid printing, where you might actually print some of the product on an analog press and then go to digital. That is actually very hard to do because the market demands print quality which looks the same, if not identical. And identical is almost impossible. And so that produces a very big problem. There's an awful lot of things that can go wrong in print quality. I originally had this picture with lots of spider bits all over the place. Karen quite happily put this back into a place which makes it look tidier. But the truth is, there are a lot of things that can go wrong. And you change one of those things, like the ink formulation slightly, or you decide to have more bits per pixel, so you add more grey levels in, or anything particular. You know, you can change any one of these parameters and you have to recalibrate the entire system again. But there is an awful lot you can do with software alone. But it does require the system to be stable. You need a stable system. That means you basically need to be able to print one image to the next thousands of times, and that at least you're getting a reproducible result. It doesn't have to be good, and it doesn't have to be perfect, but it does have to be the same. And if it is, then you can do a lot with software. So what I'm going to go through is the basic path of where you would go if you were going to look at the software-only part, assuming you've got a stable system, and how those things interlink and what is the right steps, because you need to put these things in the right place in the right order. So the first thing to look at is screeners. I'm guessing most of you know about screener technology when it comes to digital printing. Most people just simply choose the one that comes default with the software product they've got. But there's a great deal you can do with screeners, depending on what you want to do. There's two general types of screeners. There's Aerodiffusion and Autodither screeners. Aerodiffusion comes in lots of different flavours. There's lots of different techniques for doing it. They get different results. Some produce smooth skin tones. Some produce sharp line detail for text and barcodes and the likes. You need to choose your screeners very carefully. Autodither, on the other hand, is slightly less, produces slightly lesser results when it comes to image quality, except when you're up to 1200 dpi. So if you're looking at package printing and going 600 to 1200 dpi printing, Autodither is almost indistinguishable from Aerodiffusion, but it has an advantage. It's about 10 times faster, which means you can rip on the fly. So you can take your PDF file and get your data output you want much, much faster. We find a lot of our customers using Autodither because it's by default. When you basically install our product, the default screener is Autodither because it is fast, and most of our customers, a lot of them, are actually using very high resolution printing now. So that's a very important aspect to consider because it will come down to how fast you need to develop it. And it's also what type of imagery you're trying to print. The screener optimization means that you can go from something which has got sharper detail to smoother skin tones. And the difference can be quite contrasting depending on the screener you choose. And so you need to look at whether you're printing lots of text or lots of graphics, and whether in fact you're doing a lot of skin tones or a lot of colour variation, a lot of changes in a single colour through a variation. Likewise, in Aerodiffusion, there's different techniques. I mean, frequency modulated and amplitude modulated. I'm not going to get into the detail, but simply to say that there are other techniques around it, and they produce quite contrasting results as well. And the human eye is very good at seeing inconsistencies in changes in grey levels or smooth changes in a single colour. It can pick up steps quite easily. I've got some samples out which I can show you, but that problem is a big problem. Humans can see that stuff very easily. They're not very forgiving for it. So on the screener side, most of the inkjet printing systems you're using will have more than one grey level. Some people might be using binary, so basically only got one drop size. But most people who are using printheads has got maybe 3, 4, 5, 6, 7, 8 drop sizes. You don't necessarily just use one drop size within one grey level, you can mix them up. So what this picture talks about is the fact that how you choose to create, so we're showing a 50% grey level of a particular patch. I could choose to use one drop size to do that and half fill it with, say, one which has got a 50% fill, or I could use 2 of the others to do it. How I choose that will determine how smoothly the grey levels transition as I go from very low to very high grey level intensity. And it's a non-trivial thing. Most people don't do much about it. They just kind of dial up the default being the top one. But as you can see from the pictures at the bottom, again, as I said, the human eye is very discerning. It likes to see variation. So if you have drops mixed up, which this one here is, where you might have 2 grey levels mixed together at the same time, or even 3 to create that one grey level, the human eye likes that a lot better and looks a lot smoother to the human. There's many, many different ways you can do this. There's no silver bullet. The silver bullet is trying out a few options and then starting to home in on it. To some extent, luckily, with some of the other software we've developed, this becomes less of a problem because we can correct some of this in the image and manipulate the image. You'll see what I mean by that in a minute. The next bit, and the sequence is important, is to do what's called linearization. How many people here are familiar with the basic process of linearization of colour channel or a single channel? Yeah, very good, perfect. Basically, you just got to make sure that the inbound grey level maps to the outbound grey level you want, that they actually are the same. Print systems don't work all the same. Print heads all perform differently. They don't line up effectively. So you have to linearize it. So you take each colour and you do that. You can see it very profoundly if you do a process black, because you'll see that if any of the colours are not stepping evenly, your process black will have colour fringing, which is what this one is. So it's a very quick thing to see, and it's a very quick thing to fix. So the basic steps: print out your colour patches, measure the density for each of them. It'll create you a lookup table, and you take that CGAS file or whichever file you've got and you bring it into the software, and it becomes part of the data path from then on. And that's what this picture's about. So linearization, relatively straightforward, but it has to be done at that step right there. The next bit's where all the magic comes in. The picture at the top is very typical of a print head. Print heads, we've got print head manufacturers in the room, so I'll be very careful what I say, but print nozzles don't always work exactly the same as the ones next to them.
Really? Kidding.
No. And surprisingly, print heads don't work the same as the print head next to them either all the time. This is a big problem, because this is where the issue becomes with inkjet printing, is producing a quality picture. But it can be fixed in software. So what we do is we have software built into our system. You can print a test patch, you can put on a scanner, you can scan it offline or inline. It will then calculate precisely the inverted calculation. In other words, what do I need to do to change the image to negate the problem of the print head on a nozzle-to-nozzle basis. We've got a number of customers out there using this now, and the print quality just goes through the roof. I mean, they just love it, because it's actually a relatively straightforward process from the technology we've put together. It might take you, for a single print option, 15, 20 minutes to do. And then from then on, every image that goes through that data path is corrected. And you do get quite a profound change. You can see the picture at the bottom is a classic example of where we've got issues with print heads, and particularly banding within them, and then the corrected data can adjust all of that and take it all out. So that's something we have now, and it's been used quite a bit, and it has a really big impact on print quality. It's probably one of the biggest things that we're seeing demand for at the moment, is the ability to do that. So you can take head-to-head variation. You can have nozzles which are not working the same within a head. You can have bands within a head that are not working, or banks within a print head that are not working, and we can correct all of that in the image domain, which means we can do it to not just the heads we support, but basically any printing system at all, whether it's a scanning system or a single pass. Because it doesn't know about where it's going, it just knows it's had this print come to it, it needs to correct the image data, it corrects it, and then you've got corrected data from then on. The kind of second to last step, colour management, really important. We're surprised how many customers don't do colour management very well. It's not a difficult thing to do. We've got many different companies who provide colour management toolkits. But again, it's the step after. So colour management comes after density correction. You have to get the density correction so it's smooth across the entire print region, because then when you put a colour patch down, it doesn't matter where you put it. But if your print heads aren't performing the same, it would matter where you put the colour patches, because you'll measure something different and you don't want that to happen. So then when you go and print your colour patches, you spectrally measure them, then you can be sure that, a colour here, if I'd printed it over here, it doesn't matter. But if you haven't done the density correction on the heads, then you can't do that. So the last piece is missing nozzle correction. So we've done all these pieces. We've now got what looks like a very good image, except we've got stuff missing. Not good. We can correct for that. We can't fix a broken nozzle, which is very important, but we can adjust nozzles around that broken nozzle to make it look like it's not broken. And this is, again, a very useful piece of technology. It's not hard to do. Print to test pattern. You can find the nozzles that are out. We've got some technology coming through which will automate the process on the machine. So you can see the missing nozzles, and it will close loop. In other words, it will pick it up, it will correct the data path in real time, and then adjust that and remove the nozzle. So you could be printing, a nozzle can drop out. Very soon after that, within 10 to 15 seconds, it'll disappear. You'll barely see that there's that nozzle missing anymore. And that keeps your press up, which is important. And so you can take, it's a bit hard to see here, this has got a load of missing nozzles in it, which we've simulated by actually knocking out nozzles, and this is purely a software correction. So we haven't put those nozzles back again, we've just corrected around them to remove the artifact. And so we end up with this overall path of pretty much the last slide, the one after this. But that's the basic path you go through. And you can get very good image quality from a machine that looks pretty poor. But the challenge is trying to do everything mechanically can be very difficult, because there are some things you just don't have control over. The downside is you will have to do this if you change the parameter, but the upside is it doesn't take very long. We've actually gone through an entire loop of this in about 15 to 20 minutes on a printing press and got all the data path in. And what it does is our software then inserts all those corrections right there in the data path automatically, so all these pieces get in place, and then every single image, every PDF you print after that, it gets auto-corrected, whether it's on the fly, whether it's a PDF VT with variable data or not, doesn't matter what it is, it will go through that whole data path, and the RIP system will apply all of these corrections all the way through. As I said, we've got a whole suite of tools to do this, but they are totally integrated. They're part of our Atlas product, which now includes not just the image quality tools, but we also now within that Atlas product, you can completely build your own digital front end. So we have a digital front end for printing presses, where you can actually within seconds completely change, sculpt, brand the entire product of your printing press if that's what you want to do. And that's part of this Atlas product range. Just a quick mention, partners, Adobe we've got here today. ESCO is also a key partner of, and of course Global Graphics, who are also here, and I think they're speaking a bit later. So that's it for me, but if you're interested in more about this, come and catch us afterwards. I've got a couple of samples I can show you which actually show how this works, and you can see visually what's going on.
Great. Thank you.